In 3.4 day 3, we're going to look at a couple of different types of proofs. Besides our two column that we've seen, we are going to start out with that one. And then we are going to move to flowchart and paragraph and kind of see a couple of different ways that we can do proofs. Two column is still going to be kind of our main way though. So just a reminder that in a proof, statements here for a two column are on the left, reasons are on the right. Our first reason is always given. And then we want to look at what's happening from the step right before. Sometimes we can use a step further up to help us further down, and it's not always going to be the one directly above, but for the most part it is. So right here we're given a word. We're probably going to define that word, or in this case, use the midpoint theorem. And that is going to say that if we know that something is the midpoint, then the left is congruent to the right. And we want to notice that if we have congruence, we're probably going to stick with congruence throughout. We're not going to do an equals, because then we'd have an additional step to go from equals to congruence. So we kind of want to stick with whatever's given if there's not an additional step to change it. So we're going to go ahead and say that if C is the midpoint, then we know that AC and CB are congruent, and we need our lines. And then we're going to do it again because we have B is the midpoint of CD. So we have that CB is congruent to BD. And that is our midpoint theorem. And so now, if they're both congruent to CB, we can take the beginning and we can take the end, choo-choo train, and use the transitive property to put the beginning and the end congruent. So substitution would not work in this case because we have congruence and not in equals. Substitution can only work with equals. Transitive can work with both equals and congruence. So just kind of keep that in mind, that they're not always interchangeable. Next, we're going to take a look at flowchart. Flowchart is just like it looks. It kind of flows and it's more of a chart. So boxes and arrows, and it still shows that logical argument progression. The statements are in the box and the reasons are below. So this is going to be given. And then we're going to move to probably using our midpoint theorem. Again, this is actually the one right above. So AC is going to be congruent to CB, and CB is going to be congruent to BD. And so that is our midpoint theorem. And then finally, using the transitive property of congruence, POC, since we have a congruence, not equals, there. So pretty much kind of the same thing up above, just in a different format in that flowchart type proof. All right, next up we have our flowchart here where it's given this. So we kind of follow our arrows. I'm going to zoom in so we can kind of see. And we are going to move to use from congruence to equal definition of, and you can put congruent segments or just definition of congruence. Next, we're going to use some substitution. So it looks like we're going to go ahead and plug in. We have 15 equals, so we're plugging in these values here for JK and KL is equal to 3y minus 9. So a lot of times we're going to use our picture and we're going to kind of use what is already given to get to that next statement. Next up, they're using the addition property. They're adding 9 to both sides. Then they're using, they call it substitution. I would call that more simplify at that point. So just kind of getting into the habit more of what you might see as more simplify. Next, we're going to use division. So what happens when we divide both sides? We're going to actually show the work because they do the, again, simplify step. They're showing their work next. So we're just going to put the division of 3 on both sides for this step. And then they went ahead and switched it. What's it called when we switch the order? It's called symmetric property of equality. Just reverse in that order. So same kind of thing. We just put the reasons below in a flow chart, but it's super similar to a two-step. Last, we're going to take a look at a paragraph proofs. It's a way to prove a conjecture or what we're trying to prove and explains why, but more with kind of like a legal briefing outlining. So it's just more sentence format with our reasons and our statements kind of together more in sentences. So because, and we're going to start with given here. So because C, we already have our, C is the midpoint, because they're using definition of midpoint kind of next. So because C is the midpoint of A, E, and D, B, then we can do this by the definition of midpoint. We're given, and then the other given, that A, or we're given up here this, so AE is equal to DB by the definition of congruent segments. So if it's congruent, then it's equal. So it actually even kind of didn't write that other given part in there. And then by multiplication, they're multiplying 1/2 by both sides. So then lastly, substitution or simplifying. Again, I like simplify kind of better. Then CA is equal to, actually, no, that's not simplify. Excuse me, that is substitution. We're replacing the actual equivalent. Half of AE is CA. So we are substituting. We're replacing. So there is no option for simplify on that one. It is definitely substitution. This is being replaced with something equivalent. So substitution for that last reason. You're not really going to be doing a whole lot of those paragraph proofs, but just wanted you to be exposed to it and see it. But yeah, 2-column is pretty much our main type of format that we're going to be using.